Hello, hi everyone. Thanks a lot for joining today's webinar. I'm Sara Garavelli from Trusted Services, and I'm the outreach manager for the BlueBRIDGE project, which has organized this webinar. I'll say a couple of words on BlueBRIDGE for those who are not familiar with it. BlueBRIDGE is an Horizon 2020 project which delivers web-based applications, what we call virtual research environments, to serve specific communities and support them in addressing specific challenges related to the aquaculture sector, the ecosystem approach to fisheries domains in the education area, and also challenges related to maritime spatial planning, which is the topic of today's webinar. The first part of the webinar will be dedicated to the presentation of the web application that BlueBRIDGE has developed. In the second part, we will address any questions that you may have. Please use the question box function that you find in the GoToWebinar user panel to ask your questions even during the presentation. The slides and the recording of the webinar will be made available afterwards. I'm now pleased to introduce today's speakers, Miles Macmillan-Lawler, Debashish Bhakta, and Levi Westerveld. They all work for GRID-Arendal, a Norwegian foundation working closely with the United Nations Environment. Miles is a marine scientist specialized in spatial planning and seafloor mapping, and he currently leads the State of Environment and Spatial Planning Group at GRID-Arendal. Debashish has a background in forestry and geoinformatics and works at GRID-Arendal as a geographic information system specialist. And last but not least, Levi is a geographer working on spatial analysis, cartography, and capacity building support. I'll stop here and I will pass the microphone to Miles.
Thank you, Sarah, and thank you everyone for joining us today. It's an exciting time for us because we've just released this web application after nearly 2 years of hard work to get it to this stage. So this is the first time it goes out to the public and gets tested. So part of today is to raise awareness of the application we built and ask for feedback on it so we can continue to improve it in the coming months. So the presentation today is on this web application we built, and it's essentially been designed to understand ecologically important seafloor features, so things such as sea mountains, seagrass, canyons, and how they're represented in protected area networks throughout the world. I'll start off this presentation. As Sarah mentioned, we also have my colleagues Levi Westerveld and Debashish Bhakta joining us. And while we're all from GRID-Arendal, we have other partners in this project from BlueBRIDGE, the United Nations FAO, Food and Agricultural Organisation, CNR, CLS and Engineering, to name just a few of the partners. So within this presentation, we'll go through a little bit about the BlueBRIDGE project and the need for this Protected Areas Impact Maps VRE, Virtual Research Environment that is. Then we'll provide an overview of the technical details, then run through the user interface, and finally just come to some conclusions and next steps in the process for us. So firstly, just a little bit about BlueBRIDGE, and I know Sarah's mentioned a bit already, but BlueBRIDGE provides tailor-made data management services to support research, public, private sector and education. Within the BlueBRIDGE consortium, we have 14 different partners delivering a range of solutions for aquaculture, education, ecosystem approach to fisheries and maritime spatial planning. The web application we've built is very much in this maritime spatial planning space, so it's really about providing tools to do spatial analysis to underpin maritime spatial planning. The BlueBRIDGE project itself is funded under the Horizon 2020 European funding. So I guess if we look at maritime spatial planning, we know there's many uses of the marine environment. There's a competition for this maritime space through a range of sectors, especially some emerging ones. So within Europe, things like aquaculture and wind farming are seen as important and emerging sectors that are constantly growing. They're driving the idea of blue growth. Because of this competition for the space for all these activities, there's a need for efficient management and also to avoid conflicts between the sectors and between the sectors and the environment. So within the environment realm, we've got a lot of different commitments. One of the main ones we've got is the Convention on Biological Diversity, and through its Archie targets, we have Archie Target 11. And essentially countries have committed by 2020 to protect 10% of their coastal areas and marine areas, and especially areas of importance for biodiversity and ecosystem services. And so I guess this is one of the drivers of this. At the moment, when people report on protected areas, they report on the area of their marine estate under protection. And we've now developed tools so you can actually start reporting on the area of different features under your marine protected area networks. So it goes to that next level and starts looking at these important areas for biodiversity and ecosystem services. So what are marine protected areas? I guess this is one of the focuses of our talk. They're a management tool to help manage human activities in the marine environment. So essentially they're areas, spatial areas that are set aside with different restrictions on what activities can and can't be carried out in them. And their primary objective is to help maintain the biodiversity and the ecosystem services of a region whilst allowing specific human activities to occur still. In some cases, there might be complete protection where no activities are allowed, but generally, there's a gradation. So the big driver for this work was some work we did on mapping global seafloor geomorphology. Now, seafloor geomorphology is essentially looking at the different features, shape and size of features on the seafloor. So this can include things such as sea mountains, submarine canyons, gyres, plateaus, ridges, the deep ocean trenches and troughs, the mid-ocean spreading ridges, also coastal features such as the continental shelf, coral reefs. And through this we've developed a global map. So we now have a comprehensive global map of where all these different features occur. And so we thought if we combine this with where protected areas occur, we can start looking at what features are represented in these protected areas. So we've also looked at other important coastal habitats, things such as seagrass, mangroves and coral reefs. And again, there's some global layers that have been collated for these by different organisations, and we've taken these into the virtual research environment to facilitate analysis on these as well. And so this is just a map showing the distribution of those. You can see a lot of the coral reefs in the tropical areas, the seagrass and mangroves moving into the temperate regions as well. And there's a sort of a global distribution of these layers. So once again, we can use these to assess how much of this is protected in protected areas. So I guess that the challenge we've looked at and we're trying to address within this virtual research environment is to develop the tools to be able to assess which of these features are in marine managed areas, and in this case, marine protected areas. The virtual research environment itself is targeted at maritime spatial planners, at marine protected area managers, and also researchers. And one of the drivers we've had is to try and make it intuitive and user-friendly and take what is essentially complex spatial analysis and make it accessible to a broader audience. So I'll now hand over to my colleague Debashish, and he can run through the technical details of the platform.
Thank you, Miles. So, to analyze the information, we need a certain hardware and software platform, whereas virtual research environment is enable a web-enabled interface where user can analyze information and distribute among different communities and the users. For the current VRE, we need a specific community for the practice, and term community practice refer to a set of individuals who connect to solve a specific problem. We are using an infrastructure of D4 Science, where they are providing a virtual research environment and a hybrid data infrastructure. One such VRE called Protected Area Impact Map VRE, which is jointly developed by GRID-Arendal and FAO. The motivation behind the developing this VRE is to improve the understanding of marine protected area within the ecoregion and EZ with connection to seafloor features. This VRE basically provides a visualization of data and analysis of the information. It also reports a range of ecologically important seafloor features within the MPA, and this is very important for the marine spatial planning. The VRE is already in public domain, so I encourage users, please go through this VRE and provide a valuable feedback. Now, this coming couple of slides, I'm going to be explain how different components of the VRE interact with each other and produce information. As you know, the heart of the VRE is the dataset. Currently, VRE hold 27 datasets, out of which 2 are pre-processed datasets. All the datasets are projected into a WGS 1984 projection systems, and these are basically a GIS polygon layers. So the information, all the datasets are stored in a PostgreSQL. It's a very powerful platform act as a RDBMS, and whereas PostGIS is enable a Postgres to store geospatial data. We are also using a geo server which is help to publish and information across the different platform in OGC standard. So you can see that the entire information is stored in a database which is further published using a geo server and which is available for the user interface. User interface, I mean to say, it's a data miner and the RStudio and also web application. Now coming couple of slides, I'm going to be explain what is data miner and RStudio, and this web application is explained by my another colleague Levi. So to analyze the information, we need a certain logics, and logics are written in an algorithm. So we'll see how the PMBRE algorithm is evolved. So there is a component in the VRE called RStudio. So this is a very important for the entire process to develop an algorithm and for validating and testing. R is a very powerful platform for analyzing information in a statistical mode. But the less known fact about the RStudio is it's also very capable for handling geospatial data. And once user import a map packages under this environment, now it is enabled for analysis of any geospatial data. Now to know more about what is RStudio and how to use RStudio, I just encourage users, please go to support.rstudio.com. Now once algorithm is ready and it's validated, now we need to publish so that it is available for the all other users. So there is a module called statistical algorithm importer. Once algorithm is import under this environment, now user need to configure input output variables, and now then clicking some few buttons, now it is available for the use for the other third-party applications. So our algorithm is validated, tested, and is published. Now it need to access this algorithm. So there is a module called data analytics. Under data analytics, you have to access execute and experiment. Now under execute and experiment, you will find your algorithm, and now this is you can use and you can validate the output. And if you feel there is a problem in the output, then you have to go in the first step and second, and this again come to this step. So by using this three steps, this PMBRE algorithm is evolved. This is basically a set of 4 variables, whereas the first one is to upload is your own spatial data. And the interesting fact about this algorithm is this application is behind the scenes running very complex geospatial processing. So to reduce the overall computation time, we use a very powerful cloud cluster, and also we have applied a parallel programming approach to optimize the data fetching activity behind the scene. We're using a load balance geo server, and the output is always a JSON. But I encourage users to download our script from the GitHub account, and you can edit the output format, and you can also get a CSV file. And to figure out how what will the inputs for this algorithm, so I just mentioned a PDF links here in the below this slide. So the output is always a JSON. JSON is a very optimized format across transferring across the web. And but what I mean to say in this slide, if you see the variables in the data miner, and basically depend upon the type of analysis whether you want to do for easy analysis or ecoregion analysis, you have to select from the drop down, and then you have to select the type of regional ID from the PDF file, and then select the bunch of features. So I always suggested to start with the few features, not 21 features at a time. You can do, but the thing is that it will take a lot of computational time. And the output is, you can see that is a long string name, and it's basically a concatenate of file name and date at time, so that it will not override the existing file. So we have seen what is VRE and what is PMBRE, how different algorithms we have developed, and finally, in a nutshell, you can see the based on the user inputs on the data miner and web application. Now it is communicated with the R algorithm behind the scene, and further behind the scene it is interacting with the geo server and Postgres and returning information to the web application and the data miner. So this entire information is built on an open source platform. That is the beauty of this application. So now I'm handing my slide to my colleague Levi. So he will going to be explain the web application of visual aspect of this VRE. Thank you.
Hello everyone. So my name is Levi Westerveld and I also work at GRID-Arendal. So earlier today in the presentation, Miles gave us a brief overview of the context in which we build this interface. And then Debashish provided us insight into sort of the back end of the interface. And I think you understood how complex the infrastructure is and the different elements that we're dealing with. But luckily, we have also developed a front-end interface, which is the one users will be interacting with, which is much simpler and straightforward to use. So what does this interface look like? Well, some of you may already have seen it. The VRE was opened yesterday. And simply by logging into to the infrastructure, you can access this now open VRE. And once you access this VRE, this is what the sort of front page looks like. So you can see at the top side of the VRE, we have a list of different portlets. And the landing page of this portlet is this introductory guide, which is in a PDF, kind of an interactive PDF with photos and videos and some text. And this will run you through how to use this virtual research environment. So as Miles and Debashish explained already, we wanted this VRE to be very user-friendly and easy to use. And so this is a sort of an explanatory guide to how to use this virtual research environment. And I have a link here in this presentation where you can access it. The presentation will be made available after this webinar. So just on the right of this first portlet that is called About PIM VRE, we have the MPA Reporting portlets. And this is sort of the main portlet where the analysis takes place, where results of the data are shown back to the users, where users can display data sets and run a specific query. And this is sort of the main interface of the VRE, in which I will explain in more detail later in this presentation. Now you see on the right-hand side, we still have 5 other portlets. And these are default portlets that are available in most of the VREs that were developed through the BlueBRIDGE infrastructure. So the first portlet is called the members, and this is where you can see all the members that have signed up for this virtual research environment. And this is an opportunity for you to perhaps connect with other members based on shared interests or queries that you might be running for a similar location. Social networking is also very tied to the members portlet, where in there you can share information, data, links about news, for example, on marine protected areas. And this is very much like a Facebook kind of wall, but then specifically for this virtual research environment and the topics that are discussed within this context. Then on the right-hand side, we have Data Miner, and this is the very, if you want, rough or basic interface from which you can run the algorithms that we have developed for this virtual research environment. And you'll see it's quite straightforward, but it's very simple and no data is displayed back to you. Then we have the data catalog, where it's a portlet where all the users can view all the data that is hosted in the BlueBRIDGE VRE. And then on the right-hand side from that, again, we have RStudio, which, as Debashish explained, is a powerful software, statistical software, which allows you to analyze data. And in our case, we have developed R scripts, which are algorithms which allow us to analyze our data. And so if you wish, you can also use RStudio from the VRE directly to run the algorithms that we have developed if you want to, for example, customize certain elements of it rather than running it in the MPA reporting interface. Now back to that second portlet, the MPA reporting interface. Basically, the first, when you click on it, you'll see this this welcome box, which will a few paragraphs explaining you how to use this this reporting interface. And once you close it, you'll have this interactive map, which was built using open layers, which will display to you all the layers that Debashish listed earlier. And these are different types of layers, and this is a kind of a visual way to explore the data that is used by this virtual research environment. Now, here I'm showing the right-hand side of this this interactive map. You can see all the different layers, and you can turn them on and off. And then you can also switch the base map from the Esri world imagery to the Esri countries base map at the bottom of this list of layers. Now, if you wish to run a query On the top left-hand side, you'll see this little query button, and this will open a new panel in the interactive interface, which allows you to select a zone layer and then the feature layers that you want to be included in the analysis. So basically, we have two types of zone layers, and these are kind of the zones in which the analysis would be taking place. Users can either use the exclusive economic zones, also known as EEZs, or the ecoregion. And so by toggling between the economic exclusive zone or ecoregion, the map will be updated with that sort of zone of analysis layer. And then using the map or the second drop-down menu, users can select a specific zone on which they want to run an analysis. Now, when the analysis runs, it will basically, on a specific zone, it will report on the geomorphic features that were selected that intersect with all the marine protected areas that are located in that zone layer, but also on the zone layer overall. And so then users can easily see statistics, for example, on how much seamounts in one specific economic exclusive zones are protected versus the amount of seamounts that are in the exclusive economic zones that are not protected. So underneath, so in the query box, we have these feature layers, and basically by selecting different feature layers, these will be included in the analysis. And so the more feature layers you choose to select, the longer the analysis will take. But usually our analysis takes less than a minute for most of the zone layers. And so once you turn on one of the feature layers, they'll also show on the map, so you can sort of get a visual representation of that zone layer. So then once you have made your selection, you click Run Analysis, and then another page will open within that MPA reporting portlet that is called Results. So this results page has three components. First, there's an interactive table which reports to the user the values of the intersection of the analysis that was done. So here we see in square kilometers the area of each feature that intersects with the EEZ that was selected by the users, with all the MPAs combined for that EEZ, and also for each individual MPA. Now underneath we have an interactive table which sort of represents that data visually, and here we see the relationships between the features that are present in marine protected areas in that EEZ versus the area of features in the EEZ in total. And so here we see for Australia, for example, the first bar on the left-hand side for abyss shows that about 50% of abyss here are protected for this EEZ. So the user can also download a PDF or a CSV of this data. So on the top left-hand side, you see two buttons, one called PDF, one called CSV. And by clicking on these buttons, the user is capable of downloading a static PDF version of this analysis or the data for further analysis. And this is to facilitate sharing information that is produced through this virtual research environment. Now, on the interactive table, you see on the left-hand side, you have this list of different MPAs, and users can click on a specific MPA, and then the last page on this in this portlet would open, which is called Report. And here, what the users see will be the attribute data for that MPA. So, for example, we have information on the ID of the MPA, its designation, the IUCN status, when it was made year, governance status, and the managing authority. Then we have data sources under that. And then underneath, we have a map which shows the MPA. It also shows the data with which that MPA intersects. And so by clicking in the geomorphic features line, you can select which geomorphic feature you want to see, and that will then be the geomorphic feature that displays on the map. And then on the left-hand side, you will have information on abstract information about that data layer and references as well. And so it's easy to go from the interactive table to this fourth page, and the user can go back and forth if he's interested in a specific PA to report on. So that is sort of the reporting interface. Again, it was opened yesterday, so I encourage all of you to sign up for it and take a look. Feedback is very welcome, and we'll be working on the next few months to keep improving this interface based on user feedback and some of our own implementations that we want to further implement. And so I'll give it back now to Miles to finish his presentation.
Thank you, Levi, for that overview of how to use the VRE. So I'll just finish off this presentation with some sort of general conclusions and highlighting some of the next steps we're going to take in developing this virtual research environment and adding functionality. So I guess the first question is, what's the benefit of using the BlueBRIDGE platform to do this rather than doing it as a desktop GIS analysis? The first and foremost is we've been able to collate and provide access to all the relevant data and metadata in one location. So instead of having to hunt around for all these different data layers, they're all there, they're all accessible and available with the appropriate metadata and links back to their original data sources. So that's a huge benefit. The second is the rapid processing time. So running this algorithm to analyse all the protected areas in an EEZ takes a matter of seconds to maybe a minute or two for the largest, more complex EEZs. And this is as opposed to hours or days if you were to try to do this as a desktop analysis. So there's a huge benefit in terms of processing time. It also gives benefits in terms of repeatability and comparability of the processing results. So people can run the same analysis in different areas using exactly the same methods and data using the virtual research environment. It also provides then standardized reporting tools. So based on that analysis, we have a standardized reporting. So if you take one of these reports from different EEZs, you can compare them quite easily because it's the same analysis. And finally, the infrastructure can also be accessed externally because of the way it's set up for access. External projects can actually access the power of this algorithm to populate other data portals. And we've been working with the EU Joint Research Council to help access this data as part of their BioPharma project and for their different display portals. So there's added benefits in being able to have all this data centralised and the analysis accessible. So I guess the impact from this then is that the countries will be able to report on what's within their protected area networks to determine how well they're representing a standard range of these ecologically relevant seafloor features. And this then relates directly back to the CBD Archie Target 11. So very rapidly countries can see, well, how many seamounts have we got and are we representing, you know, the 10% sort of target of these ecologically important features, or are we missing them? So it allows you to not only understand how you're progressing, but also help prioritise where future MPAs could be placed. And so finally, I'll just cover off on some of the next steps we need to take. So first and foremost, now we've made this virtual research environment public, where we're very keen to get user feedback and to help improve the functionality. So one of the things we ask is people to sign up, log in, and have a play with this virtual research environment, see how it functions. There's a social media, social networking section within the virtual research environment, so feel free to use that to provide comments back to us. We certainly will take those on board and wherever possible, use those to help improve the functionality. A couple of other features we want to do is develop an email notification system when there's long processing time, so that you'll be able to start a process and go off and do other things instead of waiting for it to finish. And for this reason also, we don't have the seagrass and mangroves currently in the visual algorithm. We have it only in the data miner section. And essentially these still need to be optimized to make them a lot more efficient. And so we'll, in the next little while, we'll try and have an email notification system so you can start a process, go off to other stuff, and then you'll get an email notification when the report is ready. And finally, we're looking at developing a version of the algorithm so users can actually import their own marine protected areas and own ecological features. So at the moment, it's hardwired to use the global database on marine protected areas, and also hardwired to use the seafloor geomorphology features, the seagrass and mangrove and coral reef layers. So in a future version of the algorithm, and it'll probably be in the data miner section, not in the visual one, users will be able to upload a proposed MPA network and see how it performs. They'll also be able to upload their own ecological features. And for example, here I've put in the EMLNet habitat mapping data, which could be a useful thing to import in and report how well are we representing the different habitat types within our EEZ region. So that's our next steps in the immediate future, and we'll certainly build on those as we get feedback from the user community. So I'd like to thank everyone for taking the time to come and hear us talk on this virtual research environment. As I said, we're very excited to have finally made it public. I've got the web address here for the virtual research environment, so everyone's encouraged to log in and sign up. And as I said, feedback and suggestions are welcome. I think at this stage now we'll open to questions. I hope people have been using the little question tab to type questions. I think Sarah will go through and read some of these questions out on your behalf, and then our group of experts here will answer them. So thank you for your attention.
Yeah, thanks a lot, Miles, Debashis and Levi, for the very interesting presentation. So I see that we have a question from Andy Jeffrey, who asks, is the MPA dataset and other dynamic datasets pulled in from the WDPA at processing time, or is this data replicated within the VRE? If replicated, how often is the dataset refreshed, updated? Who wants to take the question?
Yeah, I'll answer this one. So it's not dynamically pulled from the WDPA, and that's partly because in the form the WDPA is, when you pull it straight away, it's difficult to analyse within the VRE. There's a couple of processing steps that are done in between that to get it essentially cleaned up some geometry issues so that it can be easily analysed. Our current plan is to with every sort of periodic release of it, to try and incorporate those into the virtual research environment, so we're always using the latest. And we're working closely with the Joint Research Council on this, because they actually do this cleaning for their own purpose. So we then use that process to populate the virtual research environment. So the plan is to try and maintain the most up-to-date version of that within the virtual research environment.
Okay. Thanks. We have another question from Eamon Sharef. Does PIME VRE incorporate also Copernicus marine data information?
This one again. So thank you. It doesn't currently incorporate that data. We've talked about the possibility of incorporating it, but I guess within the scope of the project currently, we focus more on the seafloor habitat data. Certainly when we build the application to bring in other data, the Copernicus marine data could be a key part of that. And I know there's certainly interest in getting that data into such a virtual research environment. Hopefully we can at least build the pathways to do that within the scope of the BlueBRIDGE project. But maybe, you know, there'll be potential for further projects to really do justice to that and bring it into this virtual research environment.
Okay. And then we have another question from Amorina Gonzalez. Will the software be able to make simulations of the possible effects of hurricanes, for example?
I think it's a very different thing for simulation of a hurricane within this VRE. Now we have just concentrated on the MPI, special distribution MPI within the easy and eco regions. So we are not thinking about that, but yes, yeah, it's a good idea. We'll keeping in account.
I think on top of that, the infrastructure that this is built on has the potential to run a whole range of different models and algorithms. So within our own virtual research environment, that's not possible, but certainly the power of the infrastructure underlying it has the capability of running a whole range of different models. And within the other components of BlueBRIDGE, there's models for fishery stock assessment, there's models looking at species modelling for climate change. So within the broader BlueBRIDGE environment and the underlying infrastructure, there is the possibility of running a whole host of different models.
Okay, and in fact we also have a comment from Anton Ellenbrock from FAO, which works on BlueBRIDGE, that say that we do climate change impact analysis in other VRE activities.
Yep.
And we do have another question from Andy that says, ask if the coverage of the zone is global. So in other words, is it possible to analyze any existing exclusive economic zone or marine protected area?
It's possible to
analyze an existing EEZ with marine protected areas.
Yes, yeah. So that is how the current infrastructure works, is that users select a specific EEZ in which they're interested and run the analysis, and then the data that will be reported to the user is basically the intersection of every feature layer that was selected for the analysis that intersects with every MPA in that selected EEZ, and then also the intersection between all the geomorphic features selected and the selected EEZ. So I think the best would be to go try the VRE, and then you I think maybe understand more in more detail how this works. But I think the VRE can in fact do what you were asking about.
Okay, and finally we have a final question that asks, what are the data formats supported by the VRE?
So the virtual research environment, as Debashish mentioned, has a back-end with GeoServer, and so it supports essentially, the GeoServer itself supports a whole range of data formats, all the standard spatial data formats, and it can be brought in as web services, as shapefiles. Within our particular VRE, those are all accessible then in the menu. Maybe Debashish can probably...
If your user interact with the data miner, then yes, there is a separate inputs for where user can upload his own shapefile for the analysis. So for currently we are support a shapefile for the user side to upload any kind of geospatial data.
Okay. Yes. We have another question that came in now from Maria. Is this platform also including some automatic features detection, ships, for example?
We have not applied this approach because our concept is different, and is automatic identification. I don't think is one of the scope of this project.
Yeah, within within one of the other VREs, looking at the Aquaculture Atlas production, they do automated detection of aquaculture facilities. So using satellite remote sensing data to detect where there's aquaculture facilities floating in the water. So certainly that sort of approach is possible using this sort of cloud computing technology, but within our virtual research environment, it's not a functionality we have.
Maria says that the question was related to the protection of the marine protected area from fishing ships.
Yep. So based on that, certainly when we enable user data to come in, we could look at enabling, bringing in shipping data, either VMS data or the AIS shipping data, and looking at how that relates to marine protected areas. So that's certainly a functionality we could look at in that regard, but we don't have specifically the ability to look at remote sensing ships. But other data could be available.
Okay, Maria says thanks. I think you addressed very well her question.
You're welcome, Maria.
Okay, so I don't think that we have any other questions. We have some participants that are thanking our speakers, so I will thank you as well, and I thank as well the participants for being with us today. As Miles said, the VRE is public, so you can access it. You will find the URL in the slides that will be shared just after the end of the webinar, and we will also share the recording. There is also, for those that are very interested in the VRE, a demo prepared by GRID-Arendal that you can find on our website. Okay, so thanks a lot, and I will close the webinar.
Thank you everyone for your participation.
Thank you.
Bye.
Bye.